Hello and welcome to this introduction to integrated multi-trophic aquaculture. My name is Dr. Adam Hughes and I'm a senior lecturer at the Scottish Association for Marine Science in Sustainable Aquaculture. In this talk, we're going to cover a number of things. We're going to talk a little bit about the Integrate project, which is why I'm speaking to you today. We're also going to understand a little bit more about aquaculture and why there's an increasing demand for aquaculture products. And we're going to kind of deal with some of the issues that face aquaculture as it develops into the 22nd century. And that will lead us on to understanding about how integrated multi-trophic aquaculture can help overcome some of the problems that aquaculture is facing. And then really we're going to look about how that might develop in the future. And we're going to break this talk into 3 bite-sized chunks. So to begin with, let's talk a little bit about the Integrate project. So the Integrate project is a European Interreg project, which is really looking at developing IMTA all across the Atlantic seaboard. So we have partners in Spain, Ireland, France, United Kingdom, Portugal, and you can see there that the Scottish Association for Marine Science, who I work for, is one of the partners of the Integrate project. So what is the Integrate project about? Well, really it's trying to develop IMTA across Europe, and it's trying to publicise the benefits and prove the benefits of this new and more sustainable system of aquaculture. So we're trying to work with industry about defining and providing some impetus to the green or blue-green growth agenda when we're trying to develop pilot-scale IMTA systems in France and Portugal, Ireland and Spain. But really, the project is about working with industry and working with stakeholders to overcome some of the barriers that are preventing IMTA from developing further. So if we're going to understand what those barriers are, we need to understand a little bit more about what the drivers are for the global expansion in aquaculture. And one of the principal drivers for that expansion can be clearly seen when we look at this graphic around population growth. By 2100, the UN is expecting the population of the world, the global population, to be around 11 billion. And currently we are somewhere around 7.5 billion. So we're expecting a significant increase in the world population. Along with that increase in population, we also expect the world population to become richer. There's a global increase in GDP at the moment, and we expect that to continue. And as people get richer, they expect more seafood within their diet. And here you can see this figure is from the FAO, and the really interesting line here is this red line. This red line is the per capita consumption of fish or seafood products. So per capita globally, back in the 1950s, per person on the planet, we were consuming around 6 kilos of fish or seafood. By 2015, that had trebled to, or more than trebled, to somewhere around 20 kilos per person. So not only is the population growing, the population is consuming and demanding more seafood. When we set this against what's happening in the global fishery, we can see there becomes a supply and demand problem. The global fishery has stagnated really since the mid-80s, the early 90s. And most of our global fish stocks are now at the maximum point that they can be exploited. So almost or nearly half of them are fully exploited. And about 20% of the global fish stocks are overexploited, meaning that they are beyond their limits of sustainability. What we can see from this is there's relatively little scope for increased production or increased seafood production from the global fisheries. And what has happened to fill that gap between the demand, which we saw from growing population, and the demand for more seafood, is that aquaculture, this blue bar, has increased significantly in the last 30 to 40 years. And it's now estimated that since around 2016, more of the fish and shellfish that we eat as a population is produced from aquaculture as opposed to fished from the sea. So if we think about that for a little bit, we have moved in the last 40 years from being hunter-gatherers of the sea to farmers of the sea. And that has huge benefits in terms of food security. It doesn't come without its own environmental impacts. And I think before we look at the environmental impacts of aquaculture specifically, we need to understand that no food production system is without environmental impact. When you're feeding 7.5 billion people now, and maybe 11 billion people in the future, how you produce that food will have a huge impact on the planet. So whatever food production system we use, whether it's fishing or farming or aquaculture, there will be a major impact. But if we look specifically at the impacts of aquaculture, it can really be boiled down to two main things. It's what we put into aquaculture and what comes out of aquaculture. Those are the two major environmental impacts. So what do we put in? Well, mainly one of the biggest inputs into aquaculture, especially in Europe, where we tend to farm more finfish and more carnivorous finfish, one of the biggest impacts is fish feed. So fish feed is made up of marine proteins, such as fish meal, marine oils, such as cod liver oil, terrestrial ingredients such as soya and maize. And the provision of that has a huge impact on the global environment, such now that around 90% of all the fish meal that is produced on the planet now goes into fish feed. So that has a large impact. The other thing which has a large impact is some of the medicines that we use to treat the fish. Like any farming operation, when you get a lot of animals together, close together, then you get diseases breeding due to proximity and the density. To treat those diseases, to ensure animal welfare and to ensure the production, you need to use medicines. So both of those inputs have environmental impacts. Also, we need to deal with what comes out of the aquaculture production system. So when you have a large number of animals housed together, you get concentrated waste products. So in the terrestrial environment, this is manure, but in the marine environment and for fish farming, it tends to be a mixture of feces, dissolved wastes, and uneaten food. You also get escaped fish, which can interbreed with wild populations, and you also get introductions and transfers of non-native species, which can have a real impact on the ecosystem. So, given that we know aquaculture has an impact on the environment, can we understand a bit better about what those impacts are? So here we've kind of taken a fish farm and looked at all what goes into it, as I mentioned before, and what goes out of it in a more stylized form. So, as I said, one of the major inputs into aquaculture is fish feed. But to get to fish feed, first of all, you have to start with capture fisheries. So this is the wild fisheries, and mainly the wild fisheries for fish meal are based in Peru and Chile. So you have wild fish going into that and energy. Then those wild fish are reduced to fish meal and fish oil with further addition of energy. Then that fish meal and fish oil is converted along with agricultural products into fish feed. That fish feed is put into the cage with the fish, and out of that we get our product, which is the fish that we want to consume. But we also get a range of waste streams, and those can be characterized as nitrogenous waste, phosphorus waste, and waste carbon. So what we have there is quite a linear economy. We have stuff going in, a production process where you get fish out, and waste streams coming quite literally out of the bottom. So given the fact that we recognise that aquaculture has this environmental impact, and traditional aquaculture is a very linear economy, a very linear production system. Why do we, as a lecturer in sustainable aquaculture, believe that aquaculture is an important component of global food security? I think what we've got to ask ourselves, if we're not producing fish through aquaculture, how do we meet that protein demand? And it's important to state that aquaculture has significant benefits in terms of food production where compared to other types of food production. So if we think about a fish is a cold-blooded organism, so it doesn't require any energy to warm its body like mammals do. So most of the food production on land is based on mammals, sheep, cows, pigs, and they all require energy to keep their body warm. So of all the feed that you give to them, a component of that is just burnt off, keeping themselves warm. Also, fish live in the sea or in fresh water. That means they're supported by the water, and that means they need less bone structure. So if you think about a cow carcass versus a salmon carcass, the salmon carcass has a much lower percentage of bone and waste compared to a cow carcass. So therefore, much more of the fish product is available for us to eat, where we don't traditionally eat the bones of the cows or pigs. So there's one or two inherent advantages in aquaculture as compared to terrestrial production. Another important thing to consider is that the impacts of aquaculture really depend on the type of aquaculture production that is going on, the environment and the techniques which are used. And so there's a lot of scope for reducing those environmental impacts and creating a much more sustainable system. And this variation allows us a lot of scope for optimization between different techniques. So that's really where the Integrate project comes in. We are looking at a system that optimizes food production through aquaculture using the most environmentally sensitive and most environmentally beneficial techniques that we can use using integrated multi-trophic aquaculture.